So I stopped the previous recording early because I know that when I run the simulator and let it free run through multiple events like that, there's a sync problem with the screen capture. And as you saw at the end of that video, the sync between the video and the audio gets fouled up. So anyway, we're starting fresh here, and we observed that there was something anomalous going on in our shift register stages, so we could look for wiring errors. But if you look at it with fresh eyes, you notice that we didn't actually make shift register blocks here. We made more adder blocks. We simply started off with the wrong elements for the shift register. Kind of a silly mistake, but anyway, easy to rectify. We'll go over here, we'll select our shift register block, paste it here, rotate it, copy that, and then we can just paste it into each of these positions. And we'll do that on this second stage of the shift register as well. And we'll save that and write a binary grid. And we'll still write it to fib.bin, replace it. And now let's bring up the simulator again. And we'll say load 00 fib.bin. And we'll bring it into our window of view here. And again, toggling this bit should cause a Fibonacci series to occur on these 8 lines, least significant bit up here. So we'll toggle the clock once, and we see a 1. We'll toggle it again, and we'll see a 2. So far, so good. Third time gives us a 3. That's good. Next one should give us a 5, but it doesn't. It still gives us a 3. And when we do this again, we get a 4, which is kind of odd. And when we get a 4, we get a 6, and the 4 plus 6 does successfully give us an 8, or gives us a 9. So it's doing something very strange at this point. And that might be discouraging, but it's clocking correctly. It is somehow remembering the 2 values. So there's a good chance that there's a wiring error somewhere. So let's go back into, let's quit out of our simulator just to clear the window. And if we go back and we start looking, and we notice that the problem was when we were switching from 2 to 3 to 5, we came out with 4 instead. And so maybe something is going wrong with the addition somewhere around these 3 least significant bits. So we seem to be feeding these bits from the output of the adder, and those are going into here, and the output's coming in here. But if we notice, we're not feeding in this second bit of the adder. We dropped a wire or failed to put one in. We need to take the output of this second bit and send that into the adder. So we will grab one more wire. I don't see one pointing up, so we'll just copy this and paste it over here, rotate it up, exit out, and then Control Z it into place. This should be a good circuit now, so we'll save it. We'll rewrite the binary grid and save that. Yes, we'll replace it. And now we can go back and do JavaSim. We can say load 00 fib.bin and bring this in. And now if we look at this and we start toggling this counter, we see a 1, a 2, a 3, there's our 5, there's our 8, there's our 8 plus 4 plus 1 is 13, there's 16 plus 5 is 21. So this does seem to be counting in a Fibonacci series. Now let me clear out the loader window here. And we can read these values using the graphical display on the side here, but that gets a little cumbersome. So we can define a vector instead. We can say vector define, let's just call it x, to be starting with its least significant bit at position 1, going down. We'll start at cell 10, so first row, 0th column. So this will be the initial bit of the cell, vector define x, 10. It'll be coming out of the data west. We're going to increment by 1 position from bit to bit. So this will be the first bit, the second bit, the third bit, and so on. And we'll have a total length of 8. Now if I say vector x, we get a decimal display of what our current value of x is, which is 21. And if I set 00 data north 1, set 00 data north 0, and then vector x again, we see that x has changed to 34. So we can put this into a little command file pretty easily. So let's just make a script called go, which says set 0, 0, data north 1, set 0, 0, data north 0, and then show me the vector value of x. And now when I say go, it automatically takes me to the next Fibonacci number. And if I grab this on a line, I can reinitialize this, load in fib.bin, and now every time that I middle click to paste this line of text into my command line, I will get my next Fibonacci number. So there's the value 1, paste again, there's 2, there's 3, there's 5, there's 8, 13, 21, 34, 55, and this will run until we exceed the 8-bit limit that we put on the adders and the registers, and then we're basically generating Fibonacci numbers modulo 256, so whatever that's worth. So that's a pretty basic example, and if we were to change the mode again to something where we can see what's happening, we can see what happens each time that we ask for another Fibonacci number. Our data is basically just flowing through here. It's two registers being added together, and we can use different display modes to observe this in different ways. But that's our basic circuit, and we can shrink out a little bit so we can zoom out with a control minus, and we can toggle the grid, turn it off, and there's a smaller condensed version of our circuit. We can probably zoom in without having the grid in there. We have enough space. So there's what our circuit looks like. Mostly wire, which is pretty typical of this kind of setup, and some registers, an adder, bit of logic, and that's about it. So there you have it, a complete start to finish description and development of a sample circuit. So later on we'll look at how we can do this with some of the place and route tools, and hopefully those tools will be improving in the next few months.